My name is Nur Hidayah binti Ahmad. My student ID is 2025125995.
Hi, my name is Muhammad Azman Fikri bin Omar, student ID 2025396893.
My name is Nur Najwa Shuhada binti Sayuti. My student ID 2025125989.
My name is Nur Nazifa Ayuni binti Edi. My student ID 2025369085.
Hi, my name is Sumi Nur Hidayah binti Safar. My student ID was 202501640007.
Hi Nazifa. For our biochemistry assignment, what topic do you want for our assignment? Do you have any choice? What topic option do we have?
We have 4 topics: enzyme, hormone, fatigue, and biomarkers.
What topic do you guys want?
Let me try to call Umi and Najwa.
Hi Najwa, which biochemistry topic do you think is the easiest for us?
I think fatigue because it's easy to ask to make assignment.
Yeah, I think Najwa's opinion is true. So we're gonna proceed this assignment as soon as possible. Bye, Nazifa.
Bye.
In introduction, we're gonna know about what is muscle fatigue. Muscle fatigue is an acute tension decline in a required or expected force or power productions during a repeated muscle action. Second point is characterized by immediate reductions in movement velocity and a drop in a total repetition volume per set. Third is evaluate to kinetic performance, decrements and acute metabolic change. So easy to define what is muscle fatigue. We can say muscle fatigue is a temporary drop in strength capacity during consecutive repetitions. It causes lower lifting phase and fewer successful push before exhaustions, measuring through mechanical breakdown and sudden chemical shift within active tissue. Another point that we want to discuss in this topic is about the ROM. The role of ROM when muscle fatigue. First point is the training at different ROM directly manipulates the operational muscle length, which is muscle shorten or longer. Second point is altering joint displacement induct substantial difference in kinetic and surface electromyographic neutral response. Third point in this subtopic, which is the role of ROM, also is traditional training utilize ROM, while partial training segment the movement into specific active zone. So easy to say that ROM altering bar travel distance modified whether target muscle work in stretch or contract state. This part modification impact lifting speed, leverage and neutral signaling pathways, isolating stress onto highlight target muscular regions rather than loading to the entire pathway. In this topic that we choose, we define they have three problem, which is the first one is the muscle hyperexia. Continuous contractions to failure compress blood vessel, cutting off blood oxygen supply. Second problem is metabolic stress, self-energetic disruptions due to heavy reliance and aerobic glycolysis. The third problem is the fatigue biomarkers. These problems happen due to the high blood lactate accumulation, uh, also low intramuscular pH, and then high inorganic phosphate impairing muscle cross-bridge cycling. In this topic also we have three objectives. The first one is to compare performance fatigue across the different bench press ROMs. Second is to evaluate acute metabolic response, which is blood lactate accumulate between the ROM condition. And last but not least is to examine neural activations and muscle requirement patterns in each ROM sector.
Methodology. First, participants. 10 resistant trained men. All had at least 3 years of bench press training and relative bench press 1 RM. Participant with musculoskeletal injuries or using nutritional supplement or drugs with exclude. Ethical approval and informed consent were obtained before the study. Second, measures. First, familiarization. Participant complete 3 familiarization sessions. Second, general and specific warm-up. General warm-up, 5 minutes of being sitting wake, followed by 5 minutes of dynamic stretching. Specific warm-up, bench press set using 50%, 75%, and 19%. Predict 1 RM before testing to prepare participants safely. Third, anthropometric measurement. Measure height, body mass, and body fat percentage. Body fat was estimated using the 7-side skin hole method. Fourth, maximum dynamic strength 1 RM. Bench press 1 RM was assessed on a Smith machine for full top and bottom ROM. Fifth, main trials. Perform 3 sets to momentary failure at 65% of their ROM specific 1 RM. 3 ROM conditions were tested: full ROM, top ROM, and bottom ROM. Test interval between set was 2 minutes. Next, movement velocity measurement. Linear position transducer tendo power analyzer. Measure mean and peak barbell velocity during every repetition. Fatigue profiles. And next one, external work and frequency of repetition calculations. Last one, blood lactate concentration. Blood samples were collected from the earlobe. After warm-up, immediately after exercise, and 3 minutes post-exercise. Blood lactate was used to assess the metabolic response to fatigue. The third methodology, design and procedures. Study used a randomized repeat measure design. Participants complete 3 experimental sessions, each 5 until 7 days apart. Each session, participants perform 3 sets of bench press to failure at 65% of their ROM specific 1 RM under one of 3 ROM condition, full top or bottom. Variable measure include 1 RM repetition barbell velocity, TUT, and blood lactate concentration. Last methodology, statistical analysis. Data were analyzed using SPSS version 23. Repeat measure ANOVA compare difference among ROM conditions and sets. To key spots, Hook test identified significant difference.
Okay, now for the result. For maximum strength, top range of motion produced the highest 1 RM, around 27% to 32%, greater than full and bottom. Consequently, top used the heaviest running load at 65% 1 RM. For barbell displacement, full range of motion had the greatest barbell travel. The displacement decreased slightly from set 1 to set 3 due to fatigue. For the repetition and work, the repetition decreased across all sets due to fatigue. Top allowed the most repetitions while full resulted in the fewest. Additionally, full performed the most work per repetition, but top achieved the highest total external work and total time under tension. Next, for time under tension (TOT), the initial TOT was successfully equalized across range of motion conditions, but final repetition it took nearly 2 times longer than initial repetition, highlighting the execution slowdown under high fatigue. For barbell velocity, mean and peak velocities were highest at the start and declined as fatigue increased. Full range of motion showed the highest initial velocity, but velocities were similar across all conditions by the final repetition. For fatigue profile, velocity declined linearly across repetition in every set. For full range of motion experienced the greatest reduction in mean and peak velocity, indicating the highest fatigue. Fatigue increased progressively from set 1 to set 3. Overall, top range of motion improved strength and training volume, whereas full range of motion induced greater fatigue.
Next, for discussion on our topic, the first point is effect of range of motion on fatigue. The first one is full of range of motion can cause the highest fatigue compared to the top and bottom range of motion. The study compared fatigue during the bench press using three different range of motion conditions, which is full, top, and bottom. The results show that full range of motion can cause the higher fatigue compared to the top and bottom range of motion. For example, participants perform fewer repetitions and the speed of the barbell becomes slower throughout the exercise. This shows that participants become fatigued more quickly during full range of motion. Next, in full range of motion, the longer movement range can increase the workload per repetition and it can cause the greater energy demand and fatigue. Which means in full range of motion, the longer movement range can increase the workload per repetition, which can cause the greater energy demand and fatigue. This is because the barbell had to travel a longer distance in every repetition, which can make the muscle work harder and lead to faster fatigue. Next point is muscle length and fatigue. The first one is bottom range of motion can increase the fatigue due to greater muscle length. This means in bottom range of motion, the muscle work at a longer length compared to the top range of motion. This makes the muscle fatigue more easily during the bench press exercise. Next, longer muscle length can reduce muscle performance and affect force production. This means when the muscles are at a longer length, they cannot produce force with efficiently. This can reduce the performance during repeated repetition of exercise. Lastly, muscle working at a longer length can lead to faster fatigue, which means as the muscle continue working at a longer length, fatigue develop more quickly. This makes it harder to maintain the same level of performance throughout the exercise. Next, for lactate and fatigue. First, exercise can increase the blood lactate due to glycolytic activity. During high intensity exercise, the body relies more on the glycolytic energy system. This can increase the blood lactate levels when more energy is produced for the working muscles. Next, all range of motion conditions show similar, which is increase in blood lactate. Although the three range of motion conditions show different level of fatigue, the increase in blood lactate was similar after the exercise. This can be because all participants perform the bench press at the same first movement tempo, which is at the end can result in a similar lactate response. Lastly, fatigue was not the only related to lactate, but also related to other physiological factors. This means lactate was not the only cause of fatigue. Other factors can cause, such as energy availability and muscle function, also contributed to the development of fatigue. Next point is relation to biochemistry. First, phosphocreatine loss can reduce the ability to produce energy quickly during exercise. This means phosphocreatine helps to produce ATP quickly during high intensity exercise. When phosphocreatine levels decrease, the muscle cannot produce energy quickly, which means this can lead to fatigue. Next, muscle function and metabolic changes contribute to fatigue, which means during repeated high intensity exercise, the muscle experience changes in their function and energy metabolism. These changes can reduce the ability of the muscle to maintain force production, which can contribute to fatigue. Lastly, energy system help to maintain performance during repeated high intensity exercise, which means different energy system work together to supply energy during repeated high intensity exercise. This help the muscle continue working and maintain performance for a longer time.
Conclusion. Top ROM allow higher load, more external work, and less decline in bubble velocity than full and bottom. Top ROM help participants lift heavy weight and maintain speed better. Next, full show higher initial velocity, but all ROM reach similar final velocities. Full ROM start faster, but speed become similar as fatigue increase. Next point, blood latte was similar across all ROM and did not explain performance difference. Latex level were similar, so they were not the main cause of performance difference. The last point is further research is need to compare top and bottom ROM for hypertrophy, strength, and power. More studies are needed to find which ROM give better long-term result. That's all for me.